check from the previous lecture if you have any uncertainty about a concept. So then there is a coefficient of variation that we have also discussed. Then we have tolerance intervals. And here, as you can see, then these are the tolerance intervals that we did. Please refer back to my lectures. Now let's just move on to the next part, which is, okay, the book that I'm using is Essentials of Business Statistics, Bowerman 5th edition, McGraw-Hill. You can buy it from Amazon or from McGraw-Hill's website, and you can also take the rented or the used version, but I think rented is the better option, or ebook if you choose to. Now, the section we are discussing is about covariance, correlation, and least squares line. So basically, when you're going to be explaining x and y and their relationship together and how they behave, whether it's positive or negative, then we take into fact the covariance. But when we talk about correlation, it's usually explaining one variable in terms of the other variable, whereas covariance would actually check the strength, and the least square line is basically the trend, whether it is negative or positive. Here we have two values. If you can see, this is a sales region, and regions, basically they have given us 10 regions, and we have expenditure per region in units of 10,000. So that 10,000 is multiplied by $10,000. So you have 50,000, 60,000, 70. So by the units of 10, this is changing. And similar for the sales volume, it can be multiplied by 10,000. You have 89,000, 87. 9, it could be, since in units of tens of thousands, you can just read that, right? So it doesn't necessarily mean that you're actually multiplying that whole thing with 10,000 also, but the difference would be explained by regions with, like they say that it is in units of 10,000. So it is basically when you have 89,000, it could be units of 10,000, because units, tens, hundreds, and thousands, and then the 8 would be the 10,000 unit. So that is how we can have these plotted here. And as you can see, this is 89, and then this is the first one is 5th. So, and then you can have various dotted lines for the imaginary line, which is the trend line, and these dots are the scatter plots or the scatter points lying very close to the line. And it shows a positive relationship that when you increase the expenditure, the sales volume would increase, but that would also vary with the, the response of the region. So if the region is, let's say 2, or let's say in here 8. See, this is not a consistent response here. It shows that even though the expenditure is increasing, the sales volume is dipped a bit, but not very much. So this is the anomaly. So that is why there is a shift in the trend line. It is going above and it is going down below as well. And this is a 45-degree line that you can just draw. Then we have covariance, which is the strength of linear relationship, is already explained. You can just simply have x minus x bar, y minus y bar. And since we are discussing the covariance in the sample, then we have S instead of sigma for population. X minus x bar, so we will be having data for x and y. And then we can just find out their x bar, which is actually summation x by n. And y bar will be summation y by n. Just add these up. And here you can just have 95 by, and in this case we are not going to be dividing summation x by n minus 1, because we're just simply taking the mean, and the mean would be in this case 95 by 10, so it's 9.5 as you can see. So x minus, because we are going to be heading towards the formula of standard deviation as summation x minus x bar whole square over n minus 1 whole under root. But in this case, as you can see that we have since covariance, it is going to vary from the standard deviation in the sense that now we don't have summation x minus x bar into summation x minus x bar. Instead, we will have summation x minus x bar into y minus y bar, because we are discussing one with respect to the other, over n minus 1. And then since this is variance sort of like thing, because we have summation x minus x bar and then again y minus y bar. So the covariance is the variance of one variable with that of the other to the central data that we have. So the central data would be the actually line that we draw as an imaginary line that should be having a perfect relationship, but we don't have a perfect relationship in this case, so we will be explaining that with the dotted line. Now, as you can see that when you sum them up, you get a 0 in this case, and you have a 0 in this case. But this could also change with the fact that this is in ascending order, but this is not necessarily in ascending order. The x is in ascending order in this case, as you see that, but y is somewhat in ascending and descending both, because you have 110 and then you have 103, so then you have 87. So this is not in quite an ascending order, so the values could tilt between negative to positive here. As you can see, this is not going from negative to positive. There are certain changes, irregularities in this, but you get a 0 in the end. Because we have a mean, so naturally it gives us a 0 in the end. Then you're going to be, since you can't take a summation x minus x bar even for standard deviation as summation x minus x bar whole square, because in this case, if you just take the square of this value, it's going to give you, or end up giving you a 0. We are going to be individually multiplying x minus x bar with y minus y bar to give us, you're not going to be multiplying the end results. So you'll be individual values, when they multiply together, the negative signs are cancelled into positive ones, and you get a certain value of 365.5. And as you can see that this is by n minus 1, because sample source there are 10 values, so 10 minus 1 is 9. Then we have correlation, in which we will be having standard deviation instead of the numerator as n minus 1, the denominator, so n minus 1 will be having these values replaced as sx into sy, because now single standard deviation has to be found out for correlation. There is a difference between covariance. Just let's look at the formulas first. So we have sxy over sx into sy, so that whatever value that we have as sxy, we're going to be dividing this whole value by sx into sy. So the original standard deviation for x variable is going to be either through the formula that we did before in the previous lecture, which has summation x over n minus summation x over n whole square or under root. Instead of that, we can also be replacing it by n minus 1, since this is not population standard deviation, it's going to be that of the sample. Secondly, we can use the other formula in which we square each value. And you can square each value here. In this case, so it's minus 4.5 into minus 4.5 plus minus 3.5 into minus 3.5. Just let me do it on the calculator, because in this calculator probably does not have the function where we can just simply add them up. Now let me just add it up in my calculator, where see, this is the first is minus 4.5. So 4.5 into 4.5, and I'm going to be ignoring the negative sign because this is, it converts into positive. Plus we have minus 3.5, 3.5 into 3.5. So first one is 4.5 into 4.5, which is 20.25. And then we have minus 3.5 into my 3.5, minus 3.5, yes. And then plus we have 2.5 into 2.5 plus 1.5 into 1.5 plus 0.5 into 0.5 plus 1.5 into 1.5 plus 2.5 into 2.5 plus, then we have 3.5 into 3.5 plus 4.5 into 4.5. You get about 82.25. Then you are going to be dividing it by n minus 1 in this case. So this would be, how many values we have? 10, so we're going to be dividing it by 9. And you get 9 point, there is a miss in this value. 9.14. Okay, let me just see if 9.14. let me just do this again. 4.5 into 4.5 plus 3.5 into 3.5 plus 2.5 into 2.5 plus 1.5 into 1.5 plus 0.5, sorry, it's, I think was missed, plus 0.5 into 0.5 plus 1.5 into 1.5 plus 2.5 into 2.5 plus 3.5 into 3.5 plus 4.5 into 4.5 is 82.5 by 9. So it is 9.1666. So it's 9.167 in other words, and you can just simply just take its under root and you get 3.02765. So this is the standard deviation. You just simply square these values and add them up. You get 9.167, and then you just take their under root, find out the standard deviation. Comes to about 3.02765. This standard deviation is required so that we can find out the correlation. Similarly, you're going to be finding out SY, which is simply just multiply each value with its own value. So it's going to be y minus y bar into again y minus y bar. So it's going to be minus 19.3 into minus 19.3, and just add them up, and you find out standard deviation, and then you're just going to be multiplying these two values after taking their under roots. So as you can see here, they have just directly done that, but you can just do it as per the steps that I've already told you. We had the individual value as 9.167, and then dividing it by 9, you get 3.02765. Similarly, we have 14.3 as SY. Then you just simply divide this and you get R. Now, if you look at this table, see, they have given you a red line and a blue line. For this scatter plot, now if you want to explain the relationship as and analyze as well, there are 4 quadrants basically. So first, second, third, and fourth. And the majority of the values are lying in the first quadrant, and these values are above y bar and x bar. So where is x bar in this case? So where these two lines intersect, you can find that this is the x-axis and this is the y-axis, and where y meets x, this is x bar, that is the mean. And where this x-axis would intersect the y-axis would be y bar as well. So this point is where it lies, the y bar and x bar as well. Now, if in the first quadrant, majority of the values are lying and they're above x bar as well as y bar. See, these dotted points are above x bar and y bar, so this is positive relationship. But if you go into the second quadrant, there's just one value which is above the, as now this is basically x bar here. So it is, this is below the x bar value. It is probably some value which is smaller than x bar, but it is above the y bar point. So this is greater than y bar and less than x bar. So in this case, it's going to be negative because one value is going to be negative, the other is positive, or they both don't align, so it can have a negative relationship. At this point where you can see, it could be similar to that point where we had increase in expenditure, but there was a decrease in the sales volume instead of increase, explained by probably, let's just see the points here. We have 12th point, as you can see that in this, 12th region we had, let's just see, 2.5, let's just go above. Yes, this is 12th region. If you can see that this is reducing actually the sales volume in this. Whereas in the other region, when the expenditure was more, they had 11, or could be multiplying by 10,000, then you can just simply have, in 10,000s of dollars of units, then that could have sales volume also as for $116,000, and this is 10,000 is going to be 16 similarly. But it is not increasing order. So it is not an increasing order, so it's not having a positive relationship in this case. As we can see from various other sales regions, that when you increase sales, they're going to have a higher response for sales. Then, as you can see from the third quadrant, we have both the values as below x bar and y bar. So it gives us a sort of negative relationship. But this would end up in a positive value where both values are negative, and here both values are positive. But is one value will be positive and the other will be negative, and in this case we don't have any value. So you can just analyze this graph, and then we have the trend line. But for the trend line, again, it's the formula for b. Now, y is equal to a plus bx. We all know that this is the least squares equation. But we need to find out what is the value of the intercept, where a is the intercept in this case. And b would be the slope, and explaining the relationship between x and y. So the correlation would actually give you the value of how well both are gelling and how well they can explain the data, or with the relationship that they have. So when we talk about the intercept, it's easier to calculate because we can have y bar applied, the bar would be applied on either side of the variables, but the constants would not have the bar with them because it's a constant value. So that when you move a towards the other side, it's going to be y minus bx, because actually y is equal to a plus bx. So moving bx towards the other side would be y minus bx, and then since we have the bar applied, so it would be y bar minus bx bar is equal to a. So we already know the y bar here from this equation. We can have the y bar and a bx bar, but we don't have the b. So what is the formula for b? B is very simple to calculate. It's just, instead of having x into sy, we'll just be having sx squared, like down below. You can see this is s square x, or sx square is just the multiplication of sx with itself, and then you have sx square. So if this is sx, so you'll just be multiplying it with itself to get sx square. And like as in here, there I think they have solved this. See, this is 3.02765 that we calculated above, whole square, and then this is sxy. So we get this value as b1, and then we can just place this value here as b naught is actually a, the intercept that we took, because this equation is a y bar minus bx bar, or you can just replace a with b naught, and the value of b would be as in this formula given, and then you can just simply place it back, and then this x bar would be the mean for x, and our intercept value would be complete. Then we can just put all these values together for y cap, which is actually the varying values in the trend line for changing values of x. I repeat, this is the varying value of y for changing values of x, and as per the condition which is given to you in the question. And then they just give you the value of 1. 1, this is now 10. Now what is this basically? They tell you that suppose that we will spend 100,000 on advertising in a sales region, and 100,000 corresponds to an x of 10. See, this is since they've said that this is 10 of 1,000, so multiplying and then dividing it, if you just simply see that if you divide it by 10,000, you just get 10. So since it was explained for tens of thousands of ten thousands of units, so we're going to be dividing it by 10 to find out what 10,000 to find out what that unit was, and that is 10. So just simply just take 10, and then you can just find out the big value, which is going to be in decimal, and then you will again multiply it with the convert it when you just multiply it with 10,000. So let me just do it for you. So it's going to be, just if you want to find out the unit, is 1105, just confirming 1105,152, and by 110.5152, and it gives you 10,000. So you just simply, what they have told you already before, that you're taking in units of 10,000. So you're going to be multiplying it with 10,000, you get this value. And when you want to convert this back, you just simply divided by 10,000 to get this value, which was actually the value for 10. And this just gives you the perfect trend line, and this is also known as the least squares line. And you already have the values for a plus b, and then you can just simply replace the values of x as you go by. Now we have 3.6 theoretical, all has been explained, and then we have another question asking about the least squares line. It's already been explained to you. We next go to the question which is 3.38. Now let me just read what they say. It's about the natural gas consumption, which is dependent upon the temperatures. So for week 1, week 2 up to week 8, we have various temperatures given to us, and we have the consumption in mmCF. Now mmCF is basically millions of cubic feet of natural gas, and millions of this is. And now they've asked you to basically calculate this in Minitab and also do it manually. But you can do that in your homes, and we can also arrange a separate class for that. This is also given to you in your chapter 1, and you can refer back to it. Now, if you just look at this best fit line, you see this is sort of like a negative relationship, because when temperatures rise, you can see that the consumption goes down. And this is C1S's consumption. They've already given to you the various, you don't have to draw the columns and calculations. They've spared you with that effort. Okay, let's just resume. Now we're going to be shifting to the board so that we can, we can attempt this question. We have different values here, x bar and x minus x bar square. We have y minus y bar, x minus x bar into y minus y bar. So let's just see what they're asking us to do. Okay class, now if you just look at this question, and I hope that you can, maybe see this with clarity. I don't think I have to increase the font size. Can we increase the font size? No? Yes, thank you. Okay class, see this is basically the gas consumption, so negative relationship with the temperatures, we have a negative sign here. For the values, basically it means that our B will be negative somewhere, and they're asking in the first part to calculate SXY, SXSY, and R. But it's not necessary that they give you in the exam everything, so what we're going to be tested on is that you have to individually calculate these values. So if you have S, just simply find out summation x by n, find out for yourself whether this is correct, x bar and y bar, just leave that part to you. But when it comes to calculations, we have SXY, SX, SY, and R. So now SXY in this case would be, we have summation I is equal to from 1 to n, in this case n is equal to 8. So we have as given was 8, and we can also check from the values whether it is 8 or not. So you just see that this is 1 to 8. So always make sure that the data is accurate. X minus x bar into y minus y bar whole. Now we have sample here, so it's going to be n minus 1. But had it been population, then we would be having n. And so this value has been already given to us, and that comes to minus 179.6%, 579.6475 by, since we had 8, so 8 minus 1 is 7. And you just simply calculate this with a calculator. So we'll be having 179.645 by 7. You can have 25.66. It's going to be negative because we have a negative value here. Then we have 0.664, let me just round it off. or 35. It's up to you how many decimal places you want to keep. Let me just be accurate here. As part, it's important because our results will be influenced by our decision to round off at what point do we decide to actually round off. Then we are asked to individually calculate Sx and Sy. So we already know the formula for Sx, which is summation I is equal to 1 to 8, and is equal to 8 of x minus x bar square. We've already done how it's calculated. It's just simply x and then the one column and then x minus x bars, like x values, and you have x minus summation x over n and then x minus x bar, this value individually, and then you have this, and then you'll have another column with x minus x bar squared, because this always gives you a 0. So not necessarily, I mean, but it could, most likely it's going to be a 0, so summation x minus x bar will be, this value is actually this value, and you divide it by 7, and this will be actually summation I is equal to 1, and is equal to 8y minus y bar squared over 7. So now the values are just going to be simply placed 1404.355 by 7, and this comes to 200.622, and this is 25.49 by 7, 549. By 7, you get 3.649. But see, this is already, this is not standard deviation, basically this is variance, so we have to take the under root of each value here. So in this case, 3.649, we'll just take the under root of this, comes to about 1.9104, and this would be 200.622, 14.164, so 14.164, and this is the standard deviation. Now we can just simply calculate, this was covariance, this was covariance, and now we actually calculate the correlation, which is R, and it's very simple, just values, individual values. In this case, this was minus 25 point, this was minus, okay, 25.6635, it's 25.6635. Remember back to the formula above if you're confused about formulas. Y is Sx into Sy, which is 14.164 into 1.9104, so it's 1.9104. So this is actually, again, if you don't remember, I can just help you recall it. R is actually Sxy over Sx into Sy, right? So you can just simply calculate by this. And now let's just see how it is. 164 into 1.9104 is .05. This is actually 27.05 here, and this is 0.5 minus 6.5 comes to about 6.5, right? And 27.05 comes to about 0.9487, or equal to approximately 0.95. So it's negative in value because there's a negative here. So this basically means that we are going to be expressing our relationship between x and y as a negative, or inversely related to y. So that means that there is an inverse relationship, because one value is increasing and the other is decreasing. And in this case, our gas consumption will be decreasing when the temperatures rise. Then we have the last part is okay. Then we are asked to calculate the least squares line, because they asked us the question, prediction of natural gas consumption during a week when the average hourly temperature is 40 degrees. And in this case, since the temperature was X here, so it's going to be 40 degrees. And let me just rub this off a bit so I can just get back to the part B. Or I can just maybe rub this portion. So what is going to be usually the least squares. In the regression equation, we have y is equal to a plus bx, where x is the independent one, y is the dependent relationship. But when we're talking about intercept and slope, we need to find out the value of intercept first. So a y bar minus bx bar, where we're just placing the bar on the variables and ignore the constants. And since the slope has a unique value, and we're also going to find out the value of a. We already know the value of y bar in this case, which is 10.2125, 2125 minus b, which is unknown at this point, into x bar, which is 43.98. 43.98. Now let's just find out the value of b, because that has already been started as x squared. And in this case, what is the value of sxy, which is minus 255.6635 over sx squared, which is again the variance. So we already had that, just 3.649, or just, no, so this 14.164. So we already had this 200.622, because 14.164 into 14.164 would give you 200.622. So we just have 200.622 and 25.6635 divided by 200.622 comes to about 0.1279. 0.1279. See, this is the value of b. And we just place this here as a is equal to 10.2125 minus point. And now this is a negative value because we already have a negative copy from there, so it's minus 0.1279 into 43.98. Okay, so now just let me have total as, since this negative and negative would become positive. So this would be 0.1279 into 43.98, 5.625, 5.6259, and 10.2125. So we have 10.2125 as 15.838 or A. Now again, we basically need to find the trend line, which is y cap is equal to a plus bx. So again, now just simply placing the value as 15.8384 into plus b, which is again the value of b is minus 0.1279, minus 0.1279 into 40, because x has been given to us as 40 degrees. So then we have 0.1279 into 40, and then we have 5.16116. It's going to be subtracted from 15.8384, and you get 10.7224. Because this was subtracted, so y cap is actually this value, but this value would change with the values of x. And part B, they were basically asking us that using the formula on page 128, we already have done the formula. You calculate the values of B1. I've already calculated this value for you, and this is the same, and B0 is 15.84. So this is basically, our B0 is actually presented by A here, which is approximately 10 point, oh no, so this is basically, where is the value that we calculated? So 15.8384, so it's 15.84, basically they just rounded it off. And then we have y cap as 10.7224. On the mini cap, we can just do that. maybe separately in June when this lockdown is over. Okay, now let me just get back to the question. This just tells you that this is a very now this value is actually falling between 45 and 39, so it's 40 degrees, and as you already know, this is 39 is 10.8 and 45.9 is 9.4. So this, what we got actually was 10.72, so this 10.72 is actually less than 10.8 and 40. So that means that this is perfectly explaining the negative relationship that exists between these two values of x and y. And we're pretty much done with this question. 3.39, I would like you to, also do it through the formula, but they've already given you the line here. You can see that they have given you the trend line, and they're asking you the service time. I guess this is the number of copiers. Let me just read the question. They have already given you the sample correlation coefficient. I would want you to just do all this, what we have done in this question, repeat for this question, as done above in the example in this question, 3.38. Now, if you see that there's a number of copiers, and we have this. Okay, so we have the number of copiers serviced and number of minutes required. So as this is the service call, and we have for 4 copiers here, we have number of minutes is 109, and then for 2 it is reducing, then for increasing. So it basically shows a positive relationship, and it's a perfectly positive relationship. It's a very strong relationship from the trend line. And they've asked us predict the service time for a future service call on which 5 copiers will be serviced. So this 5 will actually be placed here. So let me just do this for you. So it's 11.4641. 11.4641 plus, well, let me just do this on the other side. It's 11.4641 plus 24.6022 into 5, because it asks us for 5 copiers. You will simply solve this value, and this comes to about 24.6022 into 5 plus 11.464 is 124.475. So this comes to the end of this question, where we're just predicting service time, and minutes is actually minutes is explained by y, and we have y cap. Whenever we have changing values of x, it will be 5 copiers or 10 copiers or whatever. Then you can simply see how many minutes actually are required. So this will be the number of minutes that are required. And similarly, in the previous question, the negative relationship would be explained by r negative. By 95%, 94% of the data, then you can also understand from here how much data has been or can be explained. If it is 99%, that means that whether 99% of the values are being explained by by the relationship, by the correlationship, that means the interaction of x and y, and it shows the strength of the equation, and sort of like multilinearity, because at such a high percentage or the rate with r's high quotient value, the results are interdependent, and with the negative slope, it means that it's a negative relationship going down, so we'll be going downwards like this. There's a positive one, then it's going to be going down, going up like that. So that brings us to the end of this lecture, and I'll be seeing you next week. So thank you so much, class.